Hello students, welcome to my channel CGAT Maths. Myself, Dr. Suresh Biradar, Department of Mathematics, Canvasva University, Kalburgi. Students, in the last 3 to 4 videos, we are discussing double integral and triple integral. Also, evaluation of double and triple integral by changing the order of integration as well as by changing into polar form, students. Okay, so in this video we are studying beta and gamma function, students. That is the relation between beta and gamma function. Beta of m comma n is equal to gamma of m into gamma of n divided by gamma of m plus n. So we can also prove this result. Instead of beta of m comma n is equal to gamma of m into gamma of n divided by gamma of m plus n. By cross multiplication, you will get beta of m comma n into gamma of m plus 1 is equal to gamma of m into gamma of n. That is, we can also prove as gamma of m into gamma of n is equal to gamma of m plus n into beta of m comma n. So for that we required gamma of m and gamma of n, gamma of m plus n and beta of m comma n. Okay. We are going to take the second form of beta and gamma function. So students, we know that gamma of m is equal to 2 times of integral runs from 0 to infinity. You can take e raised to minus x square into x raised to 2n minus 1 into dx, and gamma of n is equal to, this is 2 times of integral runs from 0 to infinity e raised to minus y square into y raised to 2n. Here m we have taken already. This is m, this is n, student. 2n minus 1, 2n minus 1 into dy. Next, gamma of m plus n is equal to, this is 2 times of 0 to infinity. I am going to take e raised to minus r square into r raised to 2 times of m plus n minus 1 into dr, and finally beta of m comma n is equal to 2 times of 0 to infinity sin raised to 2m minus 1 theta into cos raised to 2n minus 1 into theta into d theta. So now let us take LHS, student. Observe carefully. It's a very easy one. LHS is equal to gamma of m into gamma of n, student. So gamma of m into gamma of n is, you can write gamma of m is 2 times of integral runs from 0 to infinity e raised to minus x square into x raised to 2m minus 1 into dx into 2 times of 0 to infinity e raised to minus y square into y raised to 2n minus 1 into dt dy, student. And one more thing you can remember, you can take this is in terms of n and this is in terms of m also, student. Doesn't affect. Okay, now which is equal to, so on multiplication of these two integrals, okay, 2 2s it will become 4, and you can combine these two integrals 0 to infinity, 0 to infinity, This is e raised to minus x square, e raised to minus y square, x raised to 2m minus 1, okay, into y raised to 2n minus 1 into dx into dy students. Now, this can be also written as 4 times of 0 to integral runs from 0 to infinity, 0 to infinity. This is e raised to minus, when base are same, powers are added. This is x square plus y square into x raised to 2m minus 1 to y raised to 2n minus 1 into dx into dy students. Now, further, fine. Now, what we are doing here, students, here look at the exponential power containing x square plus y square. In such a cases, we are going to convert into polar form, student. Convert into polar. So because it is like a what circle equation of a circle form, for that we are going to convert in terms of a polar. To convert into polar, we are going to substitute, student, x equal to r cos theta and y is equal to r sin theta, as well as this dx into dy as r dr into d theta, as well as these two, when we squaring and adding these two, squaring and adding, we get x square plus y square is equal to, this is r square cos square theta plus r square sin square theta. So which is same as, take r square common, you will get cos square theta plus sin square theta, students. So you know that cos square theta plus sin square theta is equal to 1. So this is r square itself. Now, and also before changing into, or before changing the limits of integration, students, you must observe very carefully here. Look at very easy one, because we already know how to draw plots respect to this. Look at here, this x runs from 0 to infinity and y runs from 0 into infinity, or either you can change in the reverse order. X runs from 0 to infinity means x equal to 0. X equal to 0 means y axis. X equal to 0 to x equal to infinity, student. It is moving in this direction. Okay, so doesn't know the final value. For the sake, we are going to write it as a what, x equal to infinity means left side to right side. Next, y is equal to 0 to infinity. Y is equal to 0 means the equation of x axis. Lower portion to upper portion is continuously moving. For the sake of convenience, we are writing y is equal to infinity. This is x equal to infinity means it calculates the area of a first quadrant. Area of first quadrant, student. Now we are going to convert in terms of polar form. As you know, in polar form, this origin becomes a pole, student. Origin becomes a pole, and this will become a radius vector r. So it is moving continuously because it need to calculate first quadrant. So r continuously moving. So r varies from pole 0 to infinity. Since you need to calculate in first quadrant, so theta varies from, student, 0 to, which is pi by 2. So therefore, the LHS means gamma of m into gamma of n is equal to the 4 times of integral runs from 0 to r and 0 to pi by 2. First one r runs from 0 to infinity, sorry, and theta runs from 0 to pi by 2. And you just substitute here e raised to minus x square plus y square is r square. You substitute x equal to r cos theta. R cos theta whole raised to 2m minus 1 r sin theta whole raised to 2n minus 1 dx dy is r dr into d theta, student. So which is equal to you keep it for as it is, and these two integrals r runs from 0 to infinity and theta runs from 0 to infinity. This is e raised to minus r square. You can separate this. This is r raised to 2m minus 1 into cos of 2m minus 1 theta into r raised to 2n minus 1 into sine of 2n minus 1 into theta, again r dr into d theta. Fine. Now we are going to combine r values. Okay. There are three values of r. So how do we combine these? Just look at which is equal to 4 times of integral r runs from 0 to infinity, r runs from 0 to pi by 2, so e raised to minus r square, write as it is, and here one r, another r, another r. So there are three values of r. When bases are same, powers are added. That is r raised to 2m minus 1 plus 2n minus 1 and plus 1, because r power is 1. Minus 1 plus 1 get cancelled. 2m and 2n, in these two 2 is common, you will get m plus n minus 1. So you can write r raised to 2 times of m plus n minus 1 into cos of 2m minus 1 theta into sine of 2n minus 1 into theta into dr into dt. Now students, here the integral is a product of both the variables r and theta. Now I am going to change the integrals here. First runs from r is equal to 0 to infinity. Second integral I am going to take it as a what? 0 to pi by 2. Here theta value keep it as it is, and the values with respect to r you can take it outside. So first here write theta sin raised to 2n minus 1 into theta into cos raised to 2m minus 1 into theta into d theta. The remaining term we can write here e raised to minus r square into r raised to 2 times of m plus n minus 1 to dr. Students, the first result is gamma of m plus n. Second result is beta of, since first value is n, we can write here n comma m. Okay. And also there is a property that beta of m comma n is also same as beta of n comma m. Okay. So for that purpose, left side is gamma of m into gamma of n. Therefore beta of m comma n is equal to gamma of m into gamma of n divided by gamma of m plus n. To keep this is as it is, beta of n comma n is replaced by m comma n and cross multiply it. So this is the required proof of relation between beta and gamma function. Thank you so much for watching. If you really like the video, please share it and subscribe it, and watch for better understanding again and again. Thank you so much.